In this video I'm going to show you how to derive the Taylor series of functions without actually having to calculate any derivatives. There are two ways to derive the Taylor series of functions. One is using the definition of Taylor series, but this is the slow and hard way. The other way is to use some known Taylor series, and this is what we're going to do here. Basically two Taylor series which everyone should know. It's the Taylor series of 1 divided by 1 minus x. This is the geometric series, and it's valid when the absolute value of x is smaller than 1. The other one is the Taylor series of e to the x, which is just the sum of n from 0 to infinity x to the n divided by n factorial. These are the Taylor series about 0, otherwise also known as Maclaurin series. Now, how do we actually use these? Let's say we would like to find what is the Taylor series of the hyperbolic cosine. Hyperbolic cosine can be written as half times e to the x plus e to the minus x. Now we can write e to the x using the Taylor series of e to the x, as well as e to the minus x using this Taylor series. As we see here, we have minus x to the n, and minus x to the n is x to the n when n is even, and minus x to the n when n is odd. And that means that for all even n, minus x to the n over n factorial is just the same thing as x to the n over n factorial. And for the odd terms, the terms in the e to the x and e to the minus x cancel each other. We're going to end up with 2 times the sum of n from 0 to infinity x to the n over n factorial, where n is even. And this we can also write out as the sum of n from 0 to infinity x to the 2n divided by 2n factorial. As you notice, we didn't have to actually differentiate the hyperbolic cosine at any point. Second trick for deriving Taylor series the easy way is this. Let's consider the function 1 divided by 1 minus x. We know that the Taylor series of this function is the geometric series. Let's look at the derivative of this function. using the quotient rule, we see that the derivative of this is the derivative of 1 is 0 times 1 minus x minus 1 times the derivative of 1 minus x, which is minus 1, divided by 1 minus x squared, or 1 over 1 minus x squared. Now if we would want to find out the Taylor series of this function, instead of actually having to go around calculating each derivative of this function, we can use the fact that this function here is just the derivative of the function 1 over 1 minus x. Taylor series of 1 over 1 minus x whole thing squared is just the derivative of the geometric series. And we know that for differentiation we can do the differentiation for each term separately, and that the derivative of x to the n is n times x to the n minus 1. I'm going to end up with n going from 1 to infinity, n times x to the n minus 1. Notice that the first term is just 0. And this would be the Taylor series of 1 over 1 minus x squared, valid when the absolute value of x is smaller than 1.